computing has become pervasive. With new tools come new forms of expression. It can also be said with new technology comes new emergent constraints. Contemporary architecture work can often be identified as a product of the software used, a consequence of accepting the coded logic, the role of the technician clear. We are interested in an architectural expression where the work transcends the platform, where the underlying principles of the work are not code constrained, but inspired in a meaningful dialogue of design aesthetics. Quite an odd topic for an engineer, you might think. However, I would argue that in the contemporary context where the world is a constant state of being processed, there must be more than a computation-driven optimization. Do I dare say engineered narrative? Design and creativity matter. Now over 6 months removed from leaving my prior firm and joining Walter P. Moore, I see my primary role to be the establishment of a design culture within my new home. More precisely, to simultaneously look to the digital tools and beyond those tools for inspiration and guidance. Let me introduce my panel. Marcelyn Gow. Marcelyn is a partner and founding member of the design collaborative Servo Los Angeles. The practice work focuses on capturing qualities that appear to be incongruous to the processes and tools used to generate them, pursuing the apparent vagaries of matter in flux, albeit through the use of highly controlled algorithmic and machinic processes. The projects integrate a combination of digital and analog techniques of design and fabrication and consider how this coexistence affects the objects that are produced, as well as their inherent aesthetic qualities. The work questions the assumed exactitude of digital processes by opening them up to unlikely conjunctions with less exact analog material behaviors. In addition to her professional work, Marcelyn teaches graduate studios and critical studies seminars at Southern California Institute of Architecture, SCI-Arc. Marcelyn Gow received her architectural degrees from Architectural Association and Columbia University, as well as a Doctor's of Science from ETH Zurich. Her doctoral dissertation, Invisible Environments, Art, Architecture, and a Systems Aesthetic, explore the relationships between aesthetic research and technological innovation. Marcelyn.
So I would like to just kick off by thanking Walter P. Moore, our generous sponsor, thanking SCI-Arc, USC, and ACADIA for making this possible. I think, and most importantly, Greg Otto. I think it's a really wonderful way to kick off a very exciting week ahead. I know some of our keynote speakers, Mark Fornes and others, are among us in the audience, so hopefully everybody will be joining those events as we go forward. So tonight I would like to just show very briefly, is this a couple images? It's not my computer, so. Oh, there we go. A couple images, more in the way of framing some issues I think that I want to bring onto the table for the discussion tonight, rather than really describing this work in any kind of detail. The image behind me is one from an exhibition that that Servo Los Angeles, my office, did here at SCI-Arc in the SCI-Arc Gallery in January of 2013, called Aquiotrope. The idea that we were looking at was a notion of what we called graying, actually referring to the idea of gray literature as something that is kind of outside the formally published world. Ephemera, marginalia, conference reports, dissertations, things that are actually classified in library science as gray literature, and also looking at how this would connect to some ideas of the status of contemporary geometry in terms of form making. So the idea of grayness really drove the exhibition. There was a book by Aris Fioretis, who is a writer who was kind of shifting his work between literary criticism and fiction. And at that moment, he was writing a book called The Gray Book, which was about this kind of liminal status of the text. And so the idea that the text, in a sense, could not be placed within a specific literary genre actually drove us to think about issues of what is the sort of contemporary status of, there had been a lot of talk in the 90s, early 2000s about geometry as the sort of driver of form. The ambiguous role of geometry as something that creates potentially a deferral of clarity. So the equivocal status of words like graining can be understood as a parallel to this ambiguous role of geometry in contemporary architectural work, we think. A gray zone that exists between computational and analog work regarding the essential connection between geometry as a virtual description of something and a series of objects that are derived from it. So this relates to something actually that Jeff Kipnis, who I'm really happy is also here in our audience tonight, has referred to as medium-specific appearance making. It's something that in the studio that I'm teaching right now with several other SCI-Arc faculty, the MArc2 studio, that we've been looking at this issue of medium-specific appearance making, the differentiation between representation, and so realism is a representational mode involving degrees of representational accuracy, and reality is something that might be represented. So the trope alludes to the possibilities of dual significance of expression, how a word might own both a literal sense as well as inviting a figurative understanding. So analogously, a single specified geometry may be instantiated as a series of objects, each being bestowed with different properties, thereby widening the interpretive space. So there's an idea of a kind of equivocation where the legibility of geometry becomes slightly confounded. In this sense, there are a series of drawings, very modular series of geometric primitives that are used to produce a diverse series of cement cast objects and blown glass objects, which become lighting fixtures, each one sort of taking on specific aspects of the geometry that is sort of describing it, but at the same time deviating from that geometry as a kind of analog behavior. So this exhibition was really about the coexistence of several artifacts where the contours of objects were treated differently. So sometimes the grayness occluded the legibility of the geometry, as does the glass when it is blown to exceed the confines of the CNC milled mold. So the first instantiation of geometry occurred in the space of the drawing, where line work is used to delineate only the extremities of the objects in question. The second instantiation was through formal features that are present in the series of objects in the space and the drawing which is on the wall behind it. So the idea was to let these things coexist, each in its own right, and to set up a kind of dialogue between drawing and object. So the idea that these series of objects are actually, the tiles are modular to a certain extent, and the lighting fixtures are modular, but they do not look so because of the analog behaviors of the material. So really a couple of issues that I think I wanted to bring onto the table for our discussion was something to do with a text I recently read by Zeynep Alexander in Log 31 called Neo-Naturalism. Alexander's talking about this sort of shift from architecture being understood in the context of the humanities to architecture being understood in the context of the natural sciences. And that right now she's arguing that the sort of major paradigm that drives a lot of architectural work would be data, sort of technical expertise in terms of the advancement of technology, computation. She talks about themes that have been on the table for quite a few years, like emergence, but really arguing for the establishment of a new technological lexicon, a new way of actually being able to understand some of these issues that are taken for granted, the issue of rendering perhaps, the issue of 3D modeling, of scanning, of sampling, that would allow for this computational work to be discussed again within the sort of humanities context as opposed to predominantly within the natural sciences. So I think that's something we could talk about tonight that would be really significant. A second issue that I think would be something we should talk about would be to do with something that has been termed, in the past, thinkers like Bob Somel, who spoke about the kind of difficult, easy dichotomy with work, shape and form, something also Andrew Zago, who's also here tonight, has talked about in some of his text with the shape being more related to the bodybuilder and form being more related to the diver. And the idea that possibly today we're looking at a situation where we don't have this dichotomy, but a lot of work I think that we're seeing currently ongoing, especially in places like here at SCI-Arc and possibly at USC, is dealing with a situation in where both these modes coexist. So we've moved away from this idea that geometry has a kind of a status of requiring legibility to say that there is a sort of clean formal logic, which might be something that, if we look back to the seminal arguments of Greg Lynn with the anexact versus the inexact, where the inexact was something that was not on the table for architects because it was not reproducible, it wasn't able to be controlled in a sense. And I think today we are looking, and we might see in some of the presentations to follow, at work where even though the processes that are used to generate the work might be extremely exact and might be reproducible, the objects that are yielded are potentially do not reveal that. So there's a certain disconnect between the legibility of exactitude. So I would say that now the inexact, potentially formal inexactitude could be something that is on the table right now, being worked with. And Mario Carpo has also argued this in his text, Breaking the Curve, the recent text from Art Forum, where he talks about the shift from spline-based logics to a kind of voxel logic, which has to do with extrapolation versus the sampling that is part of a kind of big data scenario. And so I think, we really need to look again at the connection between some of the technological advancements and then the cultural discussion that is running in parallel with that. And that's kind of what I'd like to do tonight in the panel, is to try to get us to begin to talk about some of those parallels that exist. So I think with that, I'll hand off to our next presenter. Thank you.
Our next panelist is Tom Wiscombe. Tom Wiscombe is founder and principal of Tom Wiscombe Architecture. His work stands out in terms of its synthesis of form, pattern, color, and technology into singular, irreducible constructions. His words: "Our architecture is based on creating mystery and spatial tension between elements such as building masses, interior spaces, surface articulation, and ground. We refer to this as the architecture of a flat ontology, where architecture is pulled apart into discrete parts so that it can be put back together again in unexpected ways. In this way, architecture becomes a set of interactive whole objects rather than a classical part-to-whole unity." Previously, Tom worked for Coop Himmelblau, where he was the right hand of Principal Wolf Pree for over 10 years. In addition to his work as director of Tom Wiscombe Architecture, Tom is a senior faculty member at the Southern California Institute of Architecture. He teaches design studio in IMARC 2 and also in ESTM, which, for those that don't know the acronym, Emerging Systems, Technology, and Media programs, and is applied studies coordinator in charge of curriculum building and faculty recruitment. If that was not enough, he also teaches advanced research studios as visiting professor at Penn Design. Tom received his architecture degree from the University of California, Berkeley, and his master's from the University of California, Los Angeles.
Greg, thank you very much for having me. Thanks to David and Alvin for hosting this event at SCI-Arc. I think it's a nice opportunity to cross over two different design cultures, and thanks to ACADIA. I don't know if ACADIA is a thing. I think ACADIA is whoever is doing the event at the time. So I wanted to do a little bit of what Marcelyn just did, and that is to bring up some topics that we maybe could discuss in greater detail, some things that are maybe contemporary issues around computation. I guess maybe the first question that I should answer is Greg's question about the title, which actually is now slipping my mind, but I think it's something about design aesthetics in the digital age. I think at this point, the digital age is past for architecture. And what I mean by that is that, as actually Jeff and I were just talking about this a few minutes ago, what I mean by that is that there's been a certain period of time since the early 90s, well, maybe like 93, 94, or earlier than that, maybe the 90s, about 25-year period where we've slowly come to terms with the computer. And I think that there's been a lot of experimentation. We sort of found the outer limits of what's possible, although what's possible keeps getting its bar raised. And at this point, I think it's sort of time for taking stock of what's been done and the degree to which so-called digital architecture can actually get re-engaged with the discipline of architecture, which is what I'm going to talk about in a second. So I'm going to make a couple of points. The first one is I would say that architecture is at its best when it's dealing with mystery and not with scientific or pseudoscientific issues, which I'll explain in a minute. Architecture constructs its own worlds and cannot be drawn forth from information or context alone. Would be good if we were muting the tools and breaking the tools that we're using, which is something Marcelyn just brought up. And I would go for imagination and the search for authenticity over the operation of tools inside of architecture. So first of all, mystery over scientism. I think that it goes a little bit without saying, especially within the computational community, and I don't know if that's who's in the audience tonight, but I know that that's the basis of what our ACADIA is that technology and the availability of tools, in particular processes, enable a new architecture. And while I think that tools and techniques are critical for making architecture, I think that alone does not, in fact, define an architecture. And I think that those terms get confused very often. In fact, I think that that we need to look at, in general, at what science even is. And this is something that Jeff talked about many years ago in an AADRL publication. He talked about this word research. And I think it's quite ubiquitous, actually, the word research in architecture, and it's one of the most confounding terms in architecture that I've ever heard. I don't really know what it means. It does seem to refer to things outside of the discipline of architecture, because, for instance, in science, there's something called the scientific method, which basically means that you put forth a hypothesis, you prove it through empirical means, if you can. And then it goes into the annals of science and can be and that can be turned into evidence and it can be reproduced by others. Whereas I think that architecture isn't very good at that, and especially in the sense that its output can't really be falsified. And generally, it can't be replicated by others. And it doesn't contribute to a larger body of knowledge, or let's say a giant arrow of progress of architecture towards an end where it's getting better or more improved, like knowledge. It's better at other things. It's better at things that it can do within its own discipline. It has its own unique set of capacities and discoveries and successes. So here's a neo-naturalist model of how a digital architect might work with a computer, which I have a lot of problems with, but we don't have enough time where I can go through this diagram in detail. I would say even after step I'd say even step one is a problem, and then step two is definitely a problem, abstraction. But basically what it does is it tries to put the author into an evolutionary cycle, where the author is just sort of one part of a giant computer. And the author can contribute, certainly, and it's down there at the bottom. The designer gets to judge the output after the computer does its work. But basically, it's trying to squeeze authorship and cultural production of architects into a biological or an evolutionary cycle of things getting better or more fit to their environment, which I think is a bit of a problem. So when you Google grasshopper, I was trying to remember how long ago it was that grasshopper came out, because it's been such an important tool for so many of us. I use it as well in the office. And it wasn't that long ago. It seems like forever ago. So it was 2007 is when Grasshopper hit the scene suddenly. We could realize some of our dreams about tessellation and discretization of surfaces that were before that much more smooth and supple, and we were basically unable to materialize them. And I thought, well, you know, yes, and especially this image of the linked system of moves and variable sliders and all this thing, which you do see on the walls of some schools, I think is seriously problematic. I think that it throws us off the track of architecture. It starts to put us in the mindset of looking for the origins of a project rather than looking at the project itself. So I would argue that as architects, that while we may use this in the background, that I don't think it behooves us to at all express the things that go on behind the curtain, or definitely not represent the project in that way. And I just liked very much that on the same Google search that Walt Disney's The Grasshopper and the Ants popped up as well, which I thought actually was more viable as something to start with in architecture, because it deals with figuration, it deals with representation, it deals with, it does deal with a level of abstraction. It deals with things that I would consider to be fundamental or core issues to architecture. I went to Spain recently and gave a lecture about 2 weeks ago, and I went to this building from FISAC. He's not very well known, and I didn't know what to make of it when I first arrived. I thought that it was interesting in terms of its concrete structure, sort of a rationalist extruded structure from the outside. Hard to figure out why there were level changes and different orientations as you entered it. But then I was completely blown away when I got to the interior of this project. A completely strange, mysterious interior with convex shapes built into the concrete and strange entryways into a hidden space that's totally inaccessible. I don't know, I saw the plan later, and I couldn't find these small points of access into this object, but I found it super interesting that when I looked it up later online, that it was not only not accessible, it was also not the back wall of the project, but in fact it was a gateway or an entryway into a completely hidden space inside of the building, which is incongruous with the rest of the building. So I think that was a pretty successful move, and I wasn't aware of it, but I was quite shocked and taken aback by it and really fascinated by it. Architecture constructs its own worlds and cannot be drawn forth from context or information. So I think in the 90s there was and even later than that, even today still, I think there's a lot of interest in architects in somehow justifying their work by arguing that it is drawn forth, or that it comes out of information, data collection, mapping, analysis of flows of people through a site, basically saying that the architecture cannot come fully formed, that the architecture cannot precede the site or other contingencies like program. And I disagree with that. And for me, though, it was really interesting when I went to school, this image that comes actually from Sanford Quinter's essay, Landscapes of Change, in 1992. It was a really, really important essay. And this is an epigenetic landscape from Conrad Waddington. And what Sanford was talking about at the time, which was really, really important for the field, it was intensive forces. And he was saying basically DNA expression in species is controlled to a great degree by intensive or invisible forces. And a lot of people were talking about intensive forces at that time and trying to figure out ways to use information from the site, even if it was imagined information, which a lot of times it was, use imagined information in the site in order to generate buildings. Whereas I think I would be much more interested in terms of context in a building like Mies van der Rohe National Gallery, which I think actively reconstructs its own city by becoming a kind of viewing mechanism for the city of Berlin over a building which is expressing something about its site. The tools. So I was thinking about what's the highest fidelity, most complex computation that there is currently. And then I was watching World War Z, the zombie movie, and I thought, this is probably it. I know they've been able to do armies for a long time, and now they can do these giant piles of dead bodies that move in a certain way. And then I was thinking, that reminds me, that reminds me of a discussion in the mid-90s about agents, and I know this conference is called Design Agency, about agents and emergence of things through neighbor-to-neighbor relationships, emergence of new things. And I thought, what's different between then and now? The tool is much more sophisticated, and we can do much more amazing things. But then I realized that the discourse itself on that subject, from here to here, hasn't evolved that much in terms of architecture. So I'm really curious about that, and I hope that's something we can talk about the fact that the tools have gotten immensely more powerful, but that the issues still are basically the same. And then I thought, also, it's interesting that architecture on its own accord, apart from its interest in agents and computation, has begun to deal with things, with part-to-part relationships, with piling of things, which has absolutely nothing to do with the computational angle. And I was thinking, well, why aren't those things more aligned? And I think that's something we can come to terms with today. So I'll go quickly through a couple of things. I guess a lot of my projects deal with that relationship that Marcelyn mentioned, the kind of space between shapes and forms, at least the work for the last 3 years that I've been doing. And I'm really interested in the way that something can be partially revealed. You can give glimpses of things, especially things that are inside of other things. And in this case, I wanted to show this animation, and it's properly labeled fake physics. If you do this with certain kinds of algorithms, if you do a shrink wrapping or otherwise a puffing of things, it doesn't look right. It doesn't look right. I'm sure it's completely physically accurate, but to me, as the author of the work, it doesn't look right. And so a lot of the work that we do now, although it looks like it has been, it's been manipulated through the computer at a very high level using kind of physics engines and all that, a lot of it, in fact, is analog, although it's done on the computer. A couple of strange projects around my office right now, which are in progress, I thought I would just show because they show how someone might capitalize on breaking tools. The one on the left is part of a series that we're calling The Ghosts. The ghosts are basically what happens when you take a fashion design algorithm and you use it as improperly as you possibly could, meaning you don't put an avatar in there. An avatar is a human body. So you remove the body. You don't use draping or gravity at all. You also don't puff it full of air. All you deal with is a floating ghost in space and 2D patterns that you can control. And the relationship between the 2D patterns and this three-dimensional object is quite amazing because you can keep changing the drawing, the two-dimensional drawing, the figures, and you can keep changing the figure. So that's, so far, I don't know what we'll do with it, but that's been interesting for me. And then this other thing on the right, which I'm calling the tilted slab with Loggia, this is almost a dumber one. I've been really interested in making a slab building recently for residential use and trying to figure out how something like that can hit the ground. And so always the discussion has been, how can we make it a zigzag rather than an extrusion? How does a zigzag hit the ground? And thank you, MakerBot. You and a new algorithm generated support structure to print this project in exactly the right angle and generated some we'll call it for now some structure, but what I found really interesting is a kind of urban space, like a loggia underneath an uneven contour edge on a slab building. So I have other slides as well, but I think I'm going to stop there. Thanks.
Thanks, Tom. The next panelist is Alvin Huang. Alvin is the founder and design principal of Synthesis Design and Architecture. Alvin's work can be seen as integration of material performance, emergent design technologies, and digital fabrication in contemporary architectural practice. This exploration of digital craft is identified as territory where the exchange between the technology of the digitally conceived and the artisanry of the handmade is explored. Prior to forming Synthesis, he gained significant professional experience working with Amanda Levitt Architects, Future Systems, Zaha Hadid Architects, and AECOM. In addition to his work at SDA, Alvin is currently an assistant professor at USC School of Architecture, co-director of the Architectural Association Visiting School, Los Angeles, and co-chair of this conference, 2014 ACADIA. Alvin received his Master's of Architecture and Urbanism from the Architectural Association Design Research Laboratory in London, and a Bachelor of Architecture from the University of Southern California in Los Angeles. Alvin.
Thanks, Greg. I want to thank you all for being here and for joining us this evening. Thank you to SCI-Arc for hosting us, and Greg and Walter P. Moore for organizing and their generosity. As well as my fellow panelists here tonight, who I'm very proud to share the stage with. Going to touch on a lot of topics that Tom has covered in particular, and will be a very interesting discussion to follow. And I think one of the things that this conference and my work and I think the interests that I'm pursuing both as an instructor, an educator, a researcher, a designer, follow is about a fascination with technology, and one that I think has kind of driven the progression of architecture historically. If we look back at Brunelleschi's invention of perspective, or of Otis's invention of the elevator, or of, say, any of these sorts of new fabrications that are appearing now can be compared with the invention of mass production for modernism and the sparking of modernism through mass-produced steel and glass. I think we're starting to see some of these same things happen now in the current methods of working and operating in architecture. But what I'd like to look at these as is how these things can be used to inform intuitions, specifically. And so when I talk about intuitions, I talk about this topic of what I call exploratory practice. And my work, I like to kind of look at as the kind of emergent territory, emergent pattern that exists. In this example, it's seen as a sort of moire pattern. The moire, not literally, but more figuratively, as the kind of overlay of two patterns, and the third emergent pattern that appears, where design practice and design research are explored simultaneously as exploratory practice and a sort of applied research, where technology informs a new design intuition. And so I think historically, the worlds of practice and the worlds of academia have been very divided in terms of the way they've approached many topics in design, as well as in technology. And I think in design practice, we've oftentimes looked at computation as tool, something that improves efficiency, something that improves precision, something that allows us to expedite process or expedite production. In terms of design research at an academic level, oftentimes it's about an exploration for novel techniques and thinking about how techniques can change the game and thinking about how we work with those things. What I'm very interested in is how technology informs a new design intuition, and how the evolution of tool to technique and now intuition is starting to inform a new type of practice. The sort of topics that my office and my practice is dealing with have to do with these kind of territories that I'm defining here is geometric logic, informed form, performative patterning, and digital craft, which I'll get into through the work. This is a pavilion that we constructed in London, in Bedford Square, for the AA for the 10-year anniversary of the DRL, as well as a home office installation we completed in London. Both are entirely digitally fabricated. No two-dimensional drawings were created. Everything is file-to-factory protocols. An exploration that sounds extremely digital, but in fact becomes very manual in many aspects. And that kind of gray area is where I'm really interested in terms of how we operate between producing something in 3 dimensions that we want to document in 3 dimensions and then execute through a process that has to be constructed by people who are not literate in that same 3-dimensional process. This process was aided in this case by a very, very clever script written by my good friend Mark Fornez here in the front row, who helped us look at how we could analyze all of these notches, name them, size them, unroll them, and lay them out in 2-dimensional space. And was taken forward again when we tried to do this with the home office. So when we talk about digital craft, we're really interested in these processes of how the process of making is informing the way that we're designing. And informing in a way that we are not, say, designing for the technology, we're designing with the technology. So in the case of this example here, this is a chair that's going to be on display, the first prototype of this chair at ACADIA in the exhibition. Fortunately, we weren't able to do the full-scale prototype because of time constraints. We got a half-scale prototype. It's a 3D printed chair, multi-material, printed by Stratasys, with a 10-step gradation that goes from a white soft material to a cyan rigid material. And the distribution of material properties, we're calling this a durotaxis chair. Durotaxis is a biological term, and this is in no way a biological process, but it is interesting to us because it's a biological process that it talks about the redistribution of material properties due to gradients in response to physical forces. And we're looking at these same types of studies in this project here, which is a Keelung terminal building in Taiwan, which we were again looking at how we can sculpt form to respond to physical forces, in this case environmental forces with aerodynamics, structural forces with the gradients of the monocoque carbon fiber skin. The structural engineering on this was actually done by Greg here and his team at Bureau Happold. But really looking at how not the analysis is the goal, but the analysis becomes the medium for which we curate our own struggle with and discovery of form. So we're not looking at this as a scientific process of trying to find the optimum, but looking at how we curate the analysis through our manipulation of form to discover something that fortifies our narrative and our design strategy. This here is another project in Thailand, in Bangkok. It is a 12,000 square meter expansion to a 60,000 square meter, or 600,000 square meter shopping center. So it's a very small project relative to the building it's attached to. But we were using the sort of logics of parametrics and sort of associative geometries to argue with our client and to be able to fine-tune a process that allows us to make very subtle changes to geometry and produce changes towards an output that allows us to kind of expedite the process of design. Here we have a pavilion, and now it's talking about the topic of informed form, produced for Volvo, which is this is a rapidly deployable, flat-packed, tensile fabric pavilion, which is solar-powered and charges the Volvo V60 in 12 hours and fits inside the trunk of the car, erects in 45 minutes. Engineered by Greg and his team when he was at Bureau Happold, and the team he's currently with at Walter P. Moore. The animation's not playing, but if it was playing, you would see the sort of form-finding process done through Kangaroo and the solar analysis process done through Ecotect and Grasshopper, wired together, and basically how we're, again, using the same tools to not only discover a sort of rationalized version of the form that we could build, but also an informed version of the form that we could actually begin to identify the areas of greatest solar incidence so we could locate the solar panels. That same process of the form finding and looking at mesh relaxation, we're looking at here in this project, another competition entry, this time for Daegu Opera House, or sorry, Daegu Library, not the Opera House, which was another competition we did and lost. It's a recurring theme here. Another competition which we did where we're exploring the kind of topic of the mesh relaxation, but using it not as a way for structural property, but as a way for formal properties, and looking at how we can curate the process of the mesh relaxation to try to think about this idea of a continuously walkable surface that is very much inspired by Paul Virilio's treatise, The Architecture of the Oblique, and thinking about how the oblique surface and the continuously walkable surface, also inspired by an essay written by Daniel Piker, who might be in the audience today, and his studies in rheotomic surfaces, really kind of starts to talk about an architecture that uses gravity and uses the forcefulness of gravity in terms of the way people navigate space through vertical transitions, and how vertical transitions become architectural elements as either stairs, ramps, storage, desks, etc. So all these processes we're looking at is how we are informing design decisions, but ultimately intuitive design decisions through digital processes. But the thing I want to end with is actually something I end with all the time, which is this quote from Mark Weisler, who is the godfather of ubiquitous computing. And one of the things that is striking to me about this as a process is, as Tom mentions, this sort of post-digital era that we're in. I graduated from USC in my undergraduate degree in 1998. And at that time, there was this kind of conversation going on amongst the students and you know, are you going to, when you graduate, are you going to go to a CAD office or are you going to go to an office? And everybody was like, well, I don't know. I don't really like CAD. I like to draw and I like to make models, but CAD offices, you know, they pay better. And now, like, you can't have that conversation, right? It's a stupid conversation. And right now, we're talking about digital architecture. You know, when this car came out, nearly a little bit over 100 years ago, it was called a horseless carriage. Fast forward 100-something years ago, nobody remembers the fucking horse, right? There is no horse, it's just a car. Right now, we're talking about this stuff in the terms of digital architecture, and I think as Tom mentioned, we do have to remember that the goal is not to design for the technology, it's to design with the technology. Thank you.
Our next panelist is Roland Snooks. Roland Snooks is partner of the research collaborative. I've never pronounced this thing, Kakuja? Close enough? All right. And director of the architecture practice studio, Roland Snooks. Roland's work, in his own words, we have a fascination with the impact of new technologies on architecture and construction. The practice is at the forefront of new computational design processes and robotic fabrication techniques. We are focused on how to develop and leverage these innovations to rethink what architecture might be and to create intricately crafted buildings. Roland is a lecturer in architecture at RMIT, having previously taught widely in the U.S., including Columbia University, University of Pennsylvania, and the Pratt Institute. In addition to his work with algorithmic design, Roland directs the Architectural Robotics Lab at RMIT. Roland received his PhD from RMIT, there's a theme there, in which his architectural design research is focused on behavioral processes of formation that draw from the logic of swarm intelligence. He holds a master's in advanced architectural design from Columbia University, where he studied on a Fulbright scholarship. Roland.
Popped up. There you go.
Good evening. Greg, thank you very much for the invitation. Today, this evening I want to talk a little bit about the relationship between aesthetics, form, procedure, and algorithms in the work that I do. And I want to try and trace through a couple of aesthetic strategies or formal strategies that I've operated in the work and try and relate this back to behavior. So this is the most recent project we've undertaken in the office. It's a composite fiberglass installation. And this is part of a series of projects in which we're trying to look at the intricate articulation of surfaces. And in this case, it comes out of an interest in ornament, but then that starts to get blurred. So in this case, the inlay you see into the fiberglass, this is negotiating between a series of aesthetic concerns, a series of structural concerns, a series of ornamental concerns. And there's supposed to be sort of a blurring or a vagueness between them. The predecessor to this project, this was done about a year ago. I guess this is a sort of smaller prototype, which was trying to look at the relationship between structure, ornament, and surface, and the way that these could perhaps be made to be not something that could be torn apart, but something that's irreducible. And so this is something where the structural system comes about through an excess of an ornamental system in a way. So the way all of these small bodies begin to attach their arms and legs to each other, this provides a series of structural veins going out throughout the project. And it's the small corrugations in the very thin fiberglass, which then gives it support. But it's not simply about a project about, I guess, the structural capacity or the performative quality of a material like fiberglass, but it's actually an interest in what its material, its texture, its sort of levels of transparency does in terms of aesthetics. These come out of this study. This is a study looking at the way, and it's an algorithmic study, and it's a study looking at the way a series of entities can interact and give rise to a whole series of different ornamental conditions. Some of those conditions are periodic, some of them are near symmetries, and there's a series of more sort of singular or isolated conditions. That project was from about 5 or 6 years ago. Since then, those surfaces have started to weave and wrap up and become spatial, and at times become completely immersive. So this is an attempt to try and make an architectural surface in which there's, I guess, considerable intensity and intricacy, and as a way of trying to evoke some sort of visceral response in the user. So it's meant to sort of impart or evoke some sort of response. Another thing that we keep on looking at is the line, the way the line relates to surface. So in this project, the line is trying to, it's structuring the surface. But in later projects, the line starts to break apart from the surface and starts to define the whole of the architecture. So this is an example where the form, structure, articulation is all coming about through the one system. And so it's sort of a monolithic type of reading in the project. More recently, those sort of messy strands, those high population strands have become fur or hair, and it's the fur or hair that starts to register the ornamental patterns within them. So part of this is an attempt to try and undermine the discrete reading of architectural elements. So, and this is partly an attempt to try and make something which is which negotiates between a whole set of other architectural roles. So a single architectural element is not indexable back to an architectural role. Another strategy that we've been working on for a few years is importing something from outside of architecture as a way of repressing architectural articulation. So this is sort of obviously importing a geological element. It's it's a rock. It's something which is mute, and it resists trying to articulate architecture in a normal way. So it resists trying to articulate walls as opposed to floors, as opposed to columns. It's sort of imported logic. So I guess one of the ideas that I want to try and talk about today is the way that these are all aesthetic concerns. They're all formal concerns that go through the work, but they're not something, largely, apart from perhaps the geological one, they're not something that can be separated from computation and the design process. So I think that the way Greg framed this discussion in terms of having a discussion about aesthetics, which goes beyond that of procedure or the process of the tool. I think in many ways there's something that they're irreducible. And this part of this is because everything we do is going to be in some way impacted by the tool. I mean, tools have biases, they have behaviors, they have tendencies. But what I'm interested in doing is going in through the tool and trying to rewrite those behaviors. And rewrite them not out of a set of pragmatic concerns or concerns for performance or concerns for program, but largely concerns about character and the way you might try and write behavioral characteristics within an algorithm. So this is something which I describe as behavioral formation. It's an attempt to try and encode design intention within a set of agents which interact and give rise to the emergence of, I describe as a self-organized design intention. And this is a sort of self-organized design intention which then, out of that, comes an emergent set of aesthetics, emergent set of formal traits. So this is a series of studies. They range across about a 5 or 6 year period in our work, and these are something which are quite purely algorithmic studies. So this is where we're trying to write a series of behaviors which are about a set of formal aesthetic concerns that we have, looking at the way they negotiate those, and there's some form of self-organization that operates within that and gives rise to a series of emergent characteristics. And I'd say there's sort of something similar about all of these, and I think the similarity in them is got to do with a certain complex order or emergent order that's coming out of them. Now, looking at this and then going and looking back at the previous projects, I think that there's something in the projects that far exceeds what's happening in these studies. And I think it's because these studies are, there's design intention about aesthetics and about form, which are operating within the algorithm, but there's nothing operating outside the algorithm in this process. Whereas in the projects, I think it's something about the much messier or strange feedback loops that happen when there's a intention that's happening within the algorithm. It's generating some sort of bottom-up set of patterns or characteristics, and then there's much more sort of top-down input happening in the projects, and this sort of messy feedback between them makes something which is far more, let's say, idiosyncratic or strange. And I think that, Greg, you mentioned my recently finished PhD. I think when I first started writing the PhD, I thought I was writing a PhD about an emergent form of architecture, and then I realized as I was writing, I was actually really writing a PhD about the idiosyncratic nature of the interaction between top-down decisions and those bottom-up decisions, and how it's actually a move away from the sort of purity of these types of images towards something that's far sort of stranger and idiosyncratic that I'm mostly interested in. Thank you.
So I think we got a good panel here, and obviously quite a diversity of perspectives here. So I've previously met with all four characters and gotten various viewpoints from them. I've asked them to share their thinking, their thoughts on the topic at hand as it relates to computation and architecture. And effectively, I pulled through a number of these ideas that they had and consolidated into a set of questions. And I'm going to propose that I propose these 5 questions. We'll see how far we get. I don't want to keep you all night, and I know there's a bar waiting for all of us at the very end. But I do think that there's some really interesting and very compelling topics to explore. The first one that I'd really like to start with is there's an increasing legibility of computation in architectural work. Once heralded as a means to increasing novelty, computation as a mean of architectural innovation looks to be headed in the other direction. I was sitting here tonight with Jeff Kipnis, and he was talking about his studio, and he's returned to plan and section. So he's making his students study that. I walked in here last week. Darren Johnson was drawing axons. He had all his students pin up axons on the wall. And so at some point, everybody's abandoned the idea that the computer is going to give the answers to the fundamentals. So Tom brought up the topic of fundamentals in architecture and actually addressing those fundamentals. I'd like to hear what the panel has to say about tools addressing architectural fundamentals, and what is the potential for computation potentially to address fundamentals. Tom.
Swan?
Yeah,
Okay.
you started it.
Okay. Well, I mean, other than what I already said, I think that computation in itself, I don't think is capable of very much to directly answer your question. I think that, I like what you said, Roland, at the end, that while you began your work in a certain direction, sort of servicing the theory of the work, that at the end of it, that you realize after doing projects, that the projects themselves demanded idiosyncrasies in order to resolve them as architecture. And I totally appreciate that sentiment. It makes a lot of sense to me. I think that even deciding when to use computation in a design process is super critical. And to what end? I guess I would want to avoid any wish. I'd like to call it the wish, like with a capital W. Any wish that the computer is gonna solve problems, but also a wish the computer is gonna pose problems. I think that those have to come from the architect, and I think that those problems are always in communication with the long history of architecture. When we're designing a building, I think we're always doing it in relation to a kind of constellation of other architectural projects across time, not just contemporary projects, but projects across time. And I think that's something that doesn't need to be computed. It needs to be authored. And I think that the degree to which we can access and leverage precedent in our work, I think will ultimately make our work more relevant. And then I think the computer is increasingly just becoming more interesting in the way that it can create accidents, mistakes, strange setups that it can do. I can deal with 5 million polygons now, things that it couldn't do before. I don't expect, though, that the computer, without the correct setup by the author with an agenda that is clear and stated, that the computer on its own can really do much of anything. So I don't know if I'm answering the question, but that's sort of what I think.
Yeah, I mean, I think one reason that maybe we're seeing a return to some of those really fundamental disciplinary tools, like cutting of plan or section, even drawing of axonometric, which I agree, there's something peculiar when the tool doesn't really fit the formal logics. So, of course, in the mid-90s, the whole discussion was that one plan or section is not adequate to describe this, so I need 1,000 iterative sections. And when I went to grad school, everyone did 1,000 iterative sections, and the buildings often look like that. And got, the projects actually took that on as a kind of aesthetic agenda, that you would see serial sections. I think that what has happened is there was sort of a drift where the tools for evaluating projects, across the spectrum became less clear, and there was a sense that there was sort of a loss of gravity, in a sense, that how do we begin to compare these things? So if we look to the conventions of plan or section, those historically have been used to say, okay, we can sort of derive some kind of essence from that drawing, and that can actually be used as a tool. That is something that we can evaluate things with. And I think what's called for is a sort of update on some of those tools, that rather than saying, okay, we return and there's the same way of thinking about an axonometric drawing, I think it would really require a shift that, okay, the thing that's being drawn maybe is sort of producing a tension with the tool that's being used to describe it. So ultimately the drawing that results will not be the kind of familiar axonometric that we know. And so I think there are people that are currently grappling with that. I think also right here at SCI-Arc, definitely. But yeah, I think that's sort of something we're seeing.
This conversation right now, or the particular question, or the topic of the question, kind of reminds me of a recent article I read in The Guardian. And there was an article about hipsters, and about how hipsters are now officially dead. There's no such thing as a hipster anymore because hipster is so mainstream that it is no longer a statement against the mainstream. And they said that the new hipster is what they call normcore. So the alternative is to be normal. And I find it sort of reactionary, I guess, in a sense, to like argue against computation as the thing that is debilitating in a way that you need to return towards a two-dimensional process to describe what you're doing. I think what we do as architects is we conceive three-dimensional space, we describe three-dimensional space, and then we ask someone else to recreate that three-dimensional space. And that process of authorship, when requiring a middleman, such as a projected drawing, I equate a little bit with, say, conceiving of a novel in English, writing it down in Spanish, and then asking somebody else to read it back to me in English. And we now have the tools that allow us to think in a three-dimensional way, that the entire process can be driven in 3 dimensions. The conception is in 3 dimensions, the conceptualization is in 3 dimensions, the exploration is in 3 dimensions, and the issue at hand, I feel, is actually a literacy one. And the literacy of the people that are sitting across the table from us as clients, the literacy of the people that are sitting across the table from us as consultants, and the people that are sitting across the table from us as builders. And when we can get past those hurdles, I think that's when the three-dimensional aspect, and I think that's also why I struggle with the term computation, because I actually don't think it's about computation. I think it's about three-dimensional literacy and an exploration of three-dimensional literacy that enables us as designers, and ultimately our industry and our discipline as designers and builders and makers, to enable these projects to come to fruition.
I'd like to go back to the Tom and Marcelyn's discussion, what I would describe as a messy process, but I just want to hit on Alvin and your work, which you base it really in research and looking for computation as a feedback process. I'd like for you to describe, or at least articulate, how that feedback actually works within the larger context of architecture.
Well, I guess the first thing I'd like to clarify is I would call it design research, not research. And I think there's a very, very big distinction. As Tom mentioned, scientific research is a very different category of research, and I think most scientists would look at the research we propose at events like ACADIA as horribly humorous. But I think design research...
Call it applied.
Yeah. I mean, it's about, design research, I think, in some cases shares a common term, where I think in architecture the term research is so overly abused, particularly in undergraduate schools, where research actually just means the collection of information, aka Google. And sometimes the processing of that information to identify strands and tie them together and produce a statement about that information. Whereas I think the way I'm looking at research in terms of my work, or in the work that we try to promote in I think, forums like ACADIA, is really about how design objectives and design goals are able to be tested through a series of experiments in the attempt to discover new knowledge that can inform us to develop new processes or improve processes or just execute a project. And I think that's sort of the research that we're doing in my office. I would in no way, shape, or form call scientific research. I will call it design research, in terms of we are looking for ways to explore novel processes to inform the way we're working, not necessarily in the search for novelty, but in the search for buildability, a search for ability to deliver, and a ability to think about architecture in a way where our literacy is able to be translated towards someone else's.
in the whole domain of messy computation, really stealing the words from Tom, but also going to Marcelyn and working between the digital and the analog, working from high fidelity to low fidelity. What's the potential of this kind of working?
Well, I think that, the sort of mixing of analog and digital really allows you to begin to interrogate the assumed exactitude of certain tools, where there is this kind of faith, I think that Tom brought up, that the wish that computation would sort of be able to handle a multitude of problems for the architect, and to, I mean, not problems, but to kind of have the capacity to generate things that would answer the questions the architect has on the table. And so the analog, I think, really begins to challenge that idea, and to say that, I mean, obviously, when you talk about computation, I mean, material computation as well is a huge aspect of work. So if you're working with something like molten glass or some kind of cast fluid material, there's definitely an exactitude that is present, but it's something that's less familiar to what the architect's domain is in terms of dealing with things like drawings, or with things like writing a script, or where there's a certain degree of one can anticipate things. I mean, obviously the agent-based discussion that Roland brings on the table maybe has to do with this as well, that there can be a certain moment where you challenge assumptions. And I think that is a really important thing to do in order to actually move forward in terms of a design process.
I think a lot of this discussion is really about an issue of selection versus exploration or invention in a way. And I think this is partly why we have such a kind of pushback against tools. And I think because a lot of it is, a lot of the tools we use, a lot of the computational tools, and even the analog tools that we use, are inherently indexical. Like, as soon as a tool is used, we know what has been produced from that tool, but it's the same with material. When you have a material, you select a material, you already know how that material behaves. We have some knowledge of that, how it behaves. And then, I mean, Jesse in his book talked about this as a term, as selection as a part of the aspect of the generative. But I think this is kind of a problem in that if you're always selecting something, you already know its set of characteristics and qualities and behaviors. So, Tom, I think the way you're trying to get around this is by saying, well, I'm not going to select a tool, I'm just going to wait for a tool to give me an accident. And it's one way that you no longer are selecting a known thing. So it's explorative. I mean, you're something new comes out of this. It's something potentially strange and interesting. And we're all trying to search for, strange, interesting, perhaps esoteric things. But I guess my approach to it is not to try and say, okay, I'm not going to use a tool, or I'm not going to take a tool seriously because it's indexical, but let's try and find a non-indexical way of using it, and actually try and find, like, I definitely don't think I don't think anyone can seriously argue that, tools could ever drive architecture. I mean, I don't think any of us would seriously argue that. But certainly, I think that the ideas that you have can be channeled through tools in a productive way. And I guess my interest is, how do you go about designing a new set of tools, or taking a series of behaviors that you're interested in and putting them into the tool as a way of creating a process which is not indexical. So you're no longer selecting something. You no longer have this sort of problem that I think is part of the reason why we're all reacting against computation.
Well, I mean, I don't know if you read this book called You Are Not a Gadget. Have you read this thing?
No.
I don't know. Eric Moss pressed this book in my hand a couple of years ago. I know Hernan too. It's if you guys don't know who he is, this guy is supposedly the inventor of virtual reality in the 80s. I don't know the truth of that. But anyway, he's a super dynamic guy. He writes these great and very accessible books like Steve Johnson kind of. But basically what he says in this book is that we're always kind of at the mercy of tools to a degree that we're not even aware of. He even talks about the internet as being a kind of tool that we tacitly agreed to use the structure of, and now we're locked into using the internet in a completely absurd way. For instance, the fact that we have to type in www.whatever in order to even get online to make a connection is something that's part of the original structuring of the internet by the original people at CERN like 40 years ago or whatever. And one can project from that argument this idea of lock-in, that we're locked into certain ways of using tools by looking at any number of other softwares that we use, like for instance Maya that I use and many people use, and other softwares that really have a certain kind of capacity and an immense power. They give us an immense power, there's no question about that. I don't want to come across as a Luddite here, but also I think there's an immense lock-in there in terms of things that can be produced. And I think that we have to be just super aware of that and not let the tool lead. And I think you're kind of saying that in a way, Roland. I appreciate that. But I think now in particular, and also when we start to take into account things that you're talking about, which have to do with project delivery, I think it's really important that we reevaluate again what will push architecture forward. And not what the capacities or limits of a tool, of a particular tool are. And I guess what I'm saying is that's really difficult to do once you're in the world of that particular tool. Once you're in the internet, that it's like Heidegger and broken tools and tools that are not broken. Like, once you're in the internet, it's not present to you any longer. It all makes complete sense in that world. Just the same with Maya. Once you're in the Maya environment, it's not present to you any longer. So I guess implicit to, when I say break the tool, I'm not saying like, literally, break the tool and leave the building and start drawing axos, which frankly also I find quite reactionary in some cases, depending on how it's done. But what I'm saying is that everything, these tools really are so ubiquitous, and we do take so many things for granted that it's important now after 25 years of this digital era to really again to sit back, take stock, say what has come out of this era. Look at early projects again. It's something I'd be really interested in doing. I think maybe Marcelyn is the one to write this book. I don't know, but like what is the architecture of the last 25 years without using the word digital, and find out the degree to which the tools have opened up totally new horizons, and on the other hand maybe left some things totally undiscovered because we were locked in. I don't know.
I want to make sure that we get to the bar, but I just really wanted to consolidate all of it. I know. Consolidate all of this. Having worked with all four of you, Marcelyn, you've really been the exception, but I feel like we've grown up together at the New York days and all. I think the whole attitude about how you guys go about architecture and how you interact with technology, the one thing that brings you all in common is you're great curators. You're very good at working between tools, thinking, reflecting, reassembling, repackaging, and reconsidering the things that you get as results out of the computation. You don't accept it. And I think the analogy of the internet is a very good analogy, that once you're in it, that's all you know. And I think computation can become all you know. But I think in all four cases, you guys really represent a condition of curation, or you guys really embed a rigor of curation into your work that is critical, that enables you to work in the fundamentals and increase fidelity or decrease fidelity as you need to really explore architecture. So I think that really, for me, is the really important part. The act of curation is a critical topic. I want to make sure that I open the floor to any questions the audience might have. Or are we just thirsty?
I'd like to make a comment considering fundamentals. To throw it back at you, if the column is considered a fundamental, that none of you that showed us buildings seem to be terribly adroit or confident with your columns. And I looked at Alvin's wonderful mall, organic pink shape, the interior, and the white columns inside looked like an afterthought, as though he didn't know what to do with them. And I'm going to say to Tom that your wonderful zigzag slab project was overwhelmed by centipede feet. that overtook the object of what you were trying to do. And Roland, that wonderful house on this green hill with the thunderstorm overhead, and these wonderful golden windows that flowed around were marred by your vertical columns. And they all show a lack of confidence when you compare to, say, Gaudi's crypt at Santa Coloma, where the columns are a piece of the building. I think you all missed that, but I just wanted to address a fundamental. Thank you.
So I guess you guys throw me under the bus because I engineered all of that. Any comments? The math worked.
So, do we want to answer? Someone want to answer?
Any retort?
I don't know. I mean, I think just to say something. I mean, I think like the.
I like the column.
I mean, columns. For a long period of time, there was, when the discussion was about total fluidity and sort of endlessness and total smoothness and stuff, in the 90s when that was like, basically what the major experimentation was with digital tools. And we hadn't gotten to discreteness yet, or some of the other issues of intricacy or tessellation and things that we were doing in the 2010s. Early on, I think there was a major interest in, and also in Jesse Reiser's work, and major interest in long span structures and giant plate structures and things that didn't have columns. And I think it's an interesting idea that a column is a kind of stoppage in a flow, and I think that's something that one might want to, just like when Patrick Schumacher talks about the problem of windows and doors in a truly fluid architecture. I think a column would for me be also something you might categorize with some of those other things. It's a sort of a stoppage and a problem for the total fluidity project, which I think is interesting. How do you deal with a column which essentially wants to move loads the wrong direction to maybe the way that you're moving human bodies around, for instance. So how do you deal with things like columns that are anomalies to that overarching system? It's a seriously interesting question. And I personally prefer to kind of go around the question now and not try to make every system and subsystem relate to every other one, and try to just sidestep that and say, well, we can have dissonance between architectural objects, or dissonance between the interior of a building and its exterior. We can have dissonance between the way something is constructed and the way the ornament is working on the surface. I don't know. It's just a sense that I have of where things can go. And maybe that's an answer.
Tom, maybe it also depends on what you consider to be the fundamental.
It's an exploration, Tom, that you can actually get to if you work with it rather than rely on the tool. That you have the answer, but you have to work it out. And in no case was it worked out.
But this is not a question of tool. I think it's perhaps a question of whether or what you consider to be the fundamental. I mean, is the fundamental thing the architectural object of the column, or is the fundamental thing the transfer of vertical load? Because if it's the transfer of vertical load, I'd say it's more fundamental than a column, perhaps not more fundamental to architecture. But then there's a whole lot of different ways of thinking about that. I mean, the argument I would always make is it's about how does one piece of geometry or one piece of matter, how can it negotiate between a whole set of architectural concerns, one of which might be the transfer of vertical load. So I'm not sure whether, Tom's saying he's interested in fundamentals. I'm not sure what his definition of fundamentals is. I'm not sure whether it's, the architectural fundamental of the column, or something perhaps more fundamental of the transfer of load.
Well, the word is unfortunate, fundamental, because I sound like a fundamentalist. But I do think that there are certain things that architecture can do well, and things that it also has to do. Like, for instance, I think it's very good, or it's very important to have control of mass. If you go back to Le Corbusier, and his 3 reminders to architects, mass, articulation of surface and plan. I mean, I think I would say those are some fundamentals that I would sort of agree with, even though that happens to be about exactly 100 years ago. No, not quite, 90 years ago when he wrote that in Towards a New Architecture. I think that some of that stuff is like let's think for a second about the long term of architecture. Way back beyond the 25-year history of digital architecture, stuff that people have been dealing with for ages. You know, how does an entry work? How does somebody make heavy mass look light? How does building a tall building terminate at the top? I don't know, those things that, maybe we can think of a better word for it, but those would be things that I think architects, frankly, should be interested in, because they're specific to architecture. They're not specific to the arts or to anything else. So at risk of sounding like a fundamentalist, I'll just sound like a fundamentalist.
But I mean, part of our role presumably is to invent the new problems. You have classic problems like the internal corner problem. And it's like, sure. It's only a problem if you have a right angle with a column in the corner, right? So it's based on a whole assumption about something about architecture. But if you then create an architecture which doesn't have that condition, then presumably it's creating a whole set of new problems. And so I don't think it's necessary.
And some problems disappear over time. I wouldn't say that we always have the same set of problems. I think, like, you have new problems when you have reinforcement in your concrete, and the Corbusier outlined what those are than you had before you had reinforcement. That's definitely a new problem.
I like the way you've invented a problem for yourself with the joint in composite panels. Like, it's a new problem.
Yeah, it makes no sense. Exactly. That's a problem that comes out of seeing a new material available, or getting more and more available, but being used, in my opinion, in a way that doesn't engage the discipline of architecture, which has, to me, to do with tectonics. And tectonics has to do with not just showing what a material sort of wants to do, but it also has to do with fakery and illusion. And to me, that's what's so exciting about composites. It's not needing to make giant bathtubs or surfboards with absolutely no articulation on them, but rather rethinking what is articulation in composite construction. So that would be me taking a new material, but also then trying to lodge it back into disciplinary
Let's
discourse.
entertain any other questions. It's a thirsty audience.
I think you're thirsty, Greg.
We can debate the column after the fact. All right. So I'd like to take a moment and thank our panel for their contribution. Thank you, guys. Really appreciate it. Additionally, I'd like to thank Alvin and the ACADIA team, David Gerber, in allowing SCI-Arc to host this event. I'd like to thank Ming Fung, Sarah Sullivan, and the SCI-Arc team for effectively putting this together. And finally, I'd like to acknowledge Walter P. Moore for graciously providing the beverages. Please enjoy and be safe on your way home. Good night.